Okay, so let's continue on with the lesson we just did. This is section 6.4. It's called inverse. Oh, hey, all right. Inverse trig functions. And I'll just be giving you a worksheet for extra practice tonight. Well, let's go over a few examples before we get there. So I'm going to ask you to find all angles that satisfy between 0 degrees theta and 360. So what if I asked you what angle gives us a sine of root 3 over 2? Well, I know that root 3 over 2 is going to come from our 30, 60, 90 triangle. And if I take the sine of 60 degrees, that would give us root 3 over 2. But because that's positive, we're also going to draw where sine is positive. Right there. Remember that all students take calculus. So the angles that would work would be 60 degrees, and 180 minus the 60 is 120. What if I asked you what angle gives us an inverse sine of negative root 3 over 2? Obviously, it's similar to what we just did, but if I drew 60 degrees, that would give us a sine of positive root 3 over 2. I want a sine where the opposite side is negative, so negative root 3 over 2 would be what we're looking for. We draw 60 degrees in the quadrants where sine is negative. So not here, but in these two quadrants. This angle would be 180 plus the 60, and this angle would be 360 minus the 60. Hopefully that's making a little bit more sense. What about an angle where I asked you the inverse sine of negative 1? Well, negative 1 we can't get from a special triangle. We would get 1 or 0 from quadrantal angles. And remember, sine is the y value. The y value right here is negative 1. That's at 270 degrees. That's the only angle between 0 and 360 that would work. We'll do one more. What if I asked you when is cosine root 2 over 2? Well, by now you should remember that that shows up in our 45, 45, 90 triangle. And if all students take calculus, we're going to draw 45 in the quadrants where cosine's positive. So an angle would be 45 degrees, and another angle would be 360 minus 45, or 315 degrees. Okay, and what I wanted to do to finish up today is go over some of those combination problems. And I'll just ask you to evaluate. What if I asked you what's the cosine of the inverse sine of 1/2? What we do is this is going to give us an angle. Inverse trig always gives us an angle. So what angle gives us a sine of 1/2? Well, 30 degrees would give us a sine of 1/2. So what's the cosine of this angle? Or what's the cosine of 30 degrees? And the answer would be √3/2. It doesn't always have to be a special triangle. Like what if I asked you what's the tangent of the inverse cosine of 5/3? Oh, no, let's not do 5/3. Let's use 3/5. Yeah, it's a good problem. Okay, well, this is going to give us an angle. I'm going to draw a triangle. And whatever angle this is, the cosine is 3/5, adjacent over hypotenuse. So what's the tangent of that angle? Well, this inverse cosine of 3/5 gives us this angle right there. I created that triangle based on that angle of cosine of 3/5. What's the tangent of that triangle? Well, if we use Pythagorean theorem, we know that that side is 4. The tangent of that angle would be 4/3. Do a couple more of these. Oops, we're on C. What if I asked you what's the tangent of the inverse tangent of the cosine of the inverse cosine of 1/2? All right. Well, we talked about this in the last lesson. We said that if you ever see a trig function and its inverse right next to each other, you could just cancel those off. So even though this looks scary, the answer is just 1/2. All right, we'll do one more. What if I asked you for the secant of the cotangent of 5/4, something like that? Okay, well, remember, this is going to give us our triangle. This is our angle right here. The inverse cotangent gives us that angle. Cotangent would be adjacent over opposite. So now we want to know what's the secant of that angle that the inside gave us. We have to use Pythagorean theorem here. 5 squared plus 4 squared equals the hypotenuse squared. 25 and 16. 25 and 16 is 41. So the hypotenuse, remember, is always positive. It's the square root of 41. So for this triangle, what's the secant? Well, the secant, it's the reciprocal of cosine. So it's hypotenuse over adjacent, √41/5. All right, so for homework, there's going to be a worksheet attached. Please try that, and have a nice day.